let's take a look at the board real quick, just to make sure we know what we're doing today. That way we can be on track and focused. Fun Sock Friday. Oh, we're doing Fun Sock Friday. Students will be able to solve systems of linear equations by substitution, 6.2. Hey, for this Fun Sock Friday, this is part of the trip where I mommed Kohl's. Are you guys ready for this one?
Okay, I can't see.
Get to a spot you can. Wiener dogs in buns with ketchup.
Wait, you already wore them.
No, I haven't.
I can't see.
You wore waffles.
I just took the tags off these last night. Okay. Happy Fun Sock Friday, everybody. So, yesterday, and, sorry, not yesterday, but Wednesday, and this morning, just even a little bit ago, we focused on solving systems of linear equations. We said that's two or more linear equations, and we did that by graphing. Today, we're going to start to learn how to do it by substitution. So if we flip to our second page, right where we left off yesterday, 1.5 pages through the notes. Okay, do you have your notes? We're going to solve them by substitution. So first we have to learn how do we do that. Then we're going to be practicing doing it. Okay, so just like we've substituted before, right? We substituted in an x and a y when we checked our solution. We substituted things in before for each other, correct? But normally we substitute in something like x equals 4, and we plug the 4 in for the x, and we find the y, right? This time, we'll be doing it differently. Instead of doing that, we'll be substituting in this expression for y. And the reason we're able to do this is just like in the other example, where we had, say, x equals 4, that means x is 4. It's the same thing as 4. We're able to put it in. Well, here, y is equal to 2x. That means y is the same thing as 2x. So we're able to take this 2x and put it in place of the y, because right before in this first equation, we said that y is the same thing as 2x. They're the same exact thing. Now, do we know what 2x is yet? No, that's okay. We don't need to yet. It's part of this process. So we're saying we have one variable by itself already, and y is the same thing as 2x. So we'll put that in for this y. So we'll put in 2x, where we see the y, just like we would substitute 4 in for an x, and we'd replace it with every x. We'll replace this 2x with every y we see in this equation. And that'll be equal to x plus 5. Go ahead and write that down as you follow along in your notes, please. And from here, this starts to look a lot more like some algebra equations we've seen before, doesn't it? So we have 2x is equal to x plus 5. What do you think our goal of solving this equation will be?
X on its own.
X on its own. Get x by itself. Solve for x. So, we have x's on both sides of the equation, don't we? Do we want them on both sides of the equation? No. So that means we need to move one of them. How do we move it?
Subtract or add the other x.
Subtract or add the x depending on what we're doing from which side, right? So what do you guys want to do on this equation?
Subtract the x.
Subtract just x from the right side and the left side, don't we? And here's why. Because eventually, we need to get x on its own. Well, here the x is with the 5, and here the x is by itself. So if we take the x away from the 5, then we'll get all the x's on the left side where they're by themselves. What's 2 minus 1? 1. So we just have x. What's x minus x? 0. And 5 just rolls down. So we found x to be equal to 5. We found that x was 5. I wrote up here x was 4 earlier. I'm going to scratch it out just so it doesn't confuse us. We have x equal to 5. So now what we're going to do to figure out what y is, well, actually I'm going to ask you guys, what do you think we're going to do to figure out what y is? Plug in y for the x value. Or plug in 5 for the x value, excuse me. Plug in 5 for the x value. So we can plug it back into either of our equations, actually. You have the luxury of choosing which equation we want to plug it into. Do you guys have a preference? The top one, sure. So we're going to take y is equal to 2 times 5 now. Because we're going to put this 5 in for the x. So if we put 2x in for y, we'll put 5 in for the x now in this top equation. So what is 2 times 5? That is 10. And if we were to go through and we were to check it in this one, 10 is equal to 5 plus 5. Well, that's true. So our solution, remember, we write it as an ordered pair, x comma y, 5 comma 10. And that will be our solution. Could be much worse. So you guys might be asking, Mr. Kossel, on this one, do we have to substitute this 2x in for this y? Because y is equal to x plus 5 here. So y is by itself, and we know y is the same thing as x plus 5. Yeah, we could have substituted in this x plus 5 in for the y, and we would have gotten the same exact answers. And you'll get the same answer you do here if you solve it by graphing. If you solve it by graphing or by substitution, you'll get the same exact answer either way. Does that kind of make sense? Awesome. Okay. We're doing well so far, guys. Let's keep it up. So if we look at example 2 here, y equals 2x plus 1 and y equals 3x minus 4. So one of the first things we want to keep checking for is that we have a variable by itself in at least one of the equations. We want to make sure that in at least one of the two equations we have a variable by itself. So let's look at the first equation. Do we have a variable by itself here?
Yes.
Yeah, which variable? Y. Okay, let's look at the second equation. Do we have a variable by itself?
Yep.
Yeah, which one?
Y.
Y. Okay, awesome. So we have two equations with variables by themselves. We only need one. We have two. So we can choose either one. So that means that y is the same thing as 2x plus 1, and y is also the same thing as 3x minus 4. So just like here where we said 2x is the same thing as y, and we substituted it in, we're going to say 2x plus 1 is the same thing as y. If y is equal to that, it's the same thing as it. Just like over here when we found x, we said x is 5, we can plug 5 in for x. Y is 2x plus 1, that means we can put it in wherever we see y. So we'll write 2x plus 1 is equal to what? 3x minus 4. Very good, guys. Very good. And so now, this starts to look a little more familiar to us again, right? This looks like an algebra equation we had from first semester now. How do we solve this one? Christian, what would be your first step? Which one do you want to do? Okay, so subtract 1 from each side you're thinking. Okay, so can we do the 2x and the negative 1? Do those combine? No, they're not like term. One has a variable, one doesn't. So 2x gets brought down. What's 1 minus 1? 0. 3x just gets brought down because it's not a like term with negative 1. And what's negative 4 minus 1? Negative 4 becoming more negative. Negative 5. Now how would we go about this? Josh, what would you do? Subtract 3x from both sides. We want to get the x's away from the constant and toward the other side. So this is kind of similar to where we were last time. 2x minus 3x, what are we going to get? Negative what? Negative x. Negative 1x or just negative x. 2 minus 3 is negative 1. What's 3x minus 3x? Nothing. We get rid of it. That's why we did that. And negative 5 is negative 5. So now we have negative x equals negative 5. Are we done finding x?
No.
No. What do we need to do?
Divide by negative.
Divide by a negative 1 or multiply by a negative 1. And so negative divided by negative becomes a positive x, and negative 5 divided by negative 1 becomes a what kind of 5?
Positive 5.
Positive 5. So we found x equals 5. Are we done?
No.
No. Ben, what's your question?
I was just going to say that if the x and the number are both negative, you can just automatically know that you can switch them.
Yeah, Ben's saying, hey, if we know they're both negative, we have negative x and negative 5, we get down to this step, we can just say, oh, they're both going to be positive. And that's really just doing that math in our head. So if you got to the point where you've been doing this a while and you're like, you know what, that makes sense to me, you can go ahead and do it in your head. That's awesome. X equal to 5. We need to find what variable now?
Y.
Y. How are we going to find y? Kale, how are we going to find it? Put it in. Does it matter which equation we put it into? No, we can pick. Which one do you want to pick, Kale? I'd probably pick the top one too. Why are you thinking that? Yeah, I see smaller numbers there, right? Multiplying by 2 instead of multiplying by 3, we have 1 instead of 4. Smaller numbers are generally easier for us to work with, so we'll use those. So y is equal to 2 times r5, this x, plugging in for the x, substituting, plus 1. We do the order of operations, so what's our first operation we do? Multiplication. Blake, what's 2 times 5? 10, awesome. And then Blake, what's 10 plus 1? 11. So our answer ends up being 5, 11. And once again, we can substitute this back in, 5, 11, to either equation and verify it's a solution. We were doing that yesterday, remember? We were verifying solutions, we were checking it. We could do that again here, and it would work out. For sake of time, we won't do it right now, but we could. And so if you're on a test, and you're unsure if you got the right answer, you can check your work right there. And if it's right, awesome, you did it right. If it's wrong, now you know to go back and look, right? Okay. Questions on these first two examples so far, kind of this process of substitution. Okay, let's look at this third one. We said, hey, the first thing we need to check for is that in at least one equation, we need one variable by itself. First equation, do we have any variables by themselves? No. They're both the same side of the equation, they're not by themselves. Second equation, do we have a variable by itself?
Yeah.
Awesome, that saves us some work, okay? And we'll see that actually on the next one, but it saves us some work. So, what variable is by itself? Y. And we're saying y is the same thing as x minus 4. If it equals x minus 4, it's the same thing as that. So what can we do with this x minus 4? Plug it in for the y in the other equation. So we'll have 2x, and we'll just write plus, just like we have the plus. And now, just like you would with a number, we're going to put y in, and we're going to put it in parentheses. And we'll have x minus 4 there. You write the whole thing it's equal to. You write the whole thing it's equal to. That's a really bad 5. Let me fix that. Questions on how we plug that in? Okay, awesome. So we just put it right in for y there, in parentheses again, keeping everything else the same in the equation. So, what is 2x plus x? 2x plus x is what, Jacob? 3x. We combine our like terms. Can we combine the x's in the negative form? No, they're adding. So this is just 3x minus 4 equals 5. Just chilling over here. Now this looks more like an algebra equation again to us. It looks, well, they're all algebra equations rather. But this looks like more like one we've done. Hannah, what would you do now to solve this? Add 4 to both sides. I think that's a good math move. Negative 4 plus 4 is 0. Devin, what's 5 plus 4? 9. Awesome. 9, 9, 9. Okay? We have one more math move to do before we're done with finding x. Great. Divide both sides by 3. 3 is being multiplied with x. We get rid of it from the x by dividing. 3 divided by 3 is 1. We're just left with x. And then 9 divided by 3 is 3. So we found x to be equal to 3. We done with the problem yet? No, Betsy, what do we got to do? Plug the x in to solve for y. Okay, it doesn't matter which equation we plug it into. No, do you have a preference? The second one, okay? That way we don't have to multiply it maybe. Hey, why might also the second one be a good idea? Y is already by itself. If we're finding y, and one equation has y by itself, that might be an easier route. You could do it with the top one, but this will just be a few less steps. So we'll have y is equal to 3 minus 4. And 3 minus 4 is? Negative 1. So our answer is 3, negative 1. Remember, we go x, y in our ordered pair. Now the really fun one. Actually, though, we are going to stop after this one today. But first, I want to highlight, if we had done this if we had plugged the X in for the other one, we would have got the same answer. It might have just been a couple more steps. So if you see those things, great. Okay, go ahead and do that. But if you don't, okay, do it how you normally would, and we can still get there with the right math. Questions on this process today, class? We do not have homework today.
You're the nice.
See, how is it? Everyone else. Yeah, you already know what I was talking about the 9
That can be, read chapter 10 or 11
Go ahead.
in notes over it.
I said you already know what I was talking about the 9
I mean, I have homework I could give you. Do you want me to give you guys homework?
No.
Oh, okay. My bad.
I could do it, but I don't want
And
to.
shut up.